Everyone, I'm Jerry Stanley, as Marty said. I've been with PSMA for about 10 years in various roles between looking after customers as well as building products, which has been great. The latest of those, of course, is Geoscape that I'll run through today. There's a fair bit of information about Geoscape, but I'll try to glean the most important parts as we go through. Rough agenda is we'll talk a little bit about PSMA Australia as part of it. There'll be many of you on the call that haven't really heard about us before, so we'll cover that off. Then we'll get into some Geoscape and some of the use cases and next steps, and of course follow off with some questions for any of the questions that aren't asked during. Just before I talk about PSMA Australia, it's likely that you're on the call because you either already deal with Geoscape, with geospatial data, or you've realised that geospatial data actually has a value within your business. It's been quite an emerging area for the last few years, and we've certainly seen it in PSMA over the last 2 to 3 years taking off a lot more, particularly in terms of business insights, and people really starting to wanting to use the spatial information to better manage their infrastructure and services, but also to better know where their customers are. And a lot of that comes through analytics and insights using location information, as well as numerous other bits of information that aren't necessarily location enabled. One of the quotes that I like, and I don't generally like quoting my boss, but it was a pretty good quote, is that location data remains a great untapped resource, and there are enormous benefits to the economy and society. And that's something that I truly believe in, and when we were building Geoscape, this became even more apparent as we went through. PSMA Australia is quite an interesting organisation. We're wholly government owned. However, we're owned by all the governments of Australia. Every state and territory plus the Commonwealth each own a single share in the organisation. We're not funded by any of them though, so we operate as a full commercial organisation, so we have to make money for what we do. But that also means that any of the products that we create, we actually create them so that they are commercially viable and that they're an ongoing concern. That way commercial organisations don't think that any funding decisions by government can actually impact their business. We're essentially set up to put together the national data sets and fundamental spatial data sets for Australia, and bring that together essentially by bringing in all of the feeds from the data custodians, who are predominantly the states and territories in the Commonwealth of Australia, and get that data through into solution providers. Without an entity doing something in the middle, you end up with a lot of duplication. So PSMA's role is to remove that duplication and to standardise the data nationally to make it a lot easier for people to access the data, but to remove that duplication in the process. Our current data sets are quite varied. Some of you on the call I know PSMA quite well. Others of you are reasonably new to me soon. So I will go through a little bit of our existing data before I get to Geoscape. When you start looking at it, it's probably best to see it in pictures a little bit. I always learn a bit better with pictures than what I do just via text. So if you look at an area and you understand the localities around you, they're essentially an administrative boundary. But there's many others of them. You've got things such as your statistical boundaries that the Australian Bureau of Statistics uses. You've got your local government and your state government boundaries. And you've also got electoral boundaries at federal and state level, as well as many others. But essentially, these larger areas that are really handy when you start looking at statistical or high-level aggregate data. Some of our others are some of the land administrative boundaries. So you've got cadastral parcels, which are like the land parcels around your block of land. And they are all to do with both the cadastral boundaries as well as property boundaries. And then you have the Geocoded national address file that is probably our best known product at this point with Geoscape quickly catching up to it. The Geocode national address file is about 13.5 million addresses, all with a location aspect to it and a whole heap of other stuff that I won't go into that makes it really cool. And then we have a data set called transport and topography. It's about 2.5 million kilometres of road centreline, as well as the rail network, the air network, as well as water boundaries, which includes your streams and rivers and above earth drainage unit, and also your green space, which is your urban and national parks. But of course, when you start talking about the urban and national parks, they're things that can change over time. You still don't know what's there. And with all of our data, we started being asked a particular question. I've dealt with a lot of the largest spatial firms in Australia for a lot of years, and a lot of people that deal with addresses, and that includes your banks and your insurance companies and everywhere else. And they all started having the same sort of question, and really it was about what's at an address. So when we embarked on the concept of Geoscape, we really started to think about what is at an address and what is it that people might be thinking of. So really what came about was the built environment, and people seem to want to know about buildings, about trees that could impact upon them or be risks, as well as knowing where the standard elevations were of things, so sort of where they sat, so it could be analysed for things such as flood mapping or even bushfires and the like. But not only did they want to know about the buildings being there, they wanted to know what sort of size the buildings were, and then a couple of other things came out around solar panels and swimming pools and a range of other things that we didn't actually think. When we started defining this, we started talking to a couple of particular groups of people. One of those were emergency management, response, and the insurance industry. And of course, the insurance industry were quite interested to understand risk to buildings. The emergency services industry care about pre-planning for emergencies, so they can plan to respond quicker and better, but also post emergency to actually do the mop-up a lot quicker. When you start talking about some of the state and local governments, there's a lot of work being done at the moment around things such as smart cities, and really it's around urban planning, but it's around connectivity as well as just about where buildings are. So there's a lot of things around planning and where things should be and where space is currently void that could possibly be of use. So they had a lot of input into things such as understanding the information required to do things like 30-minute cities and the like. And then, of course, telecommunications were very interested, and things such as your 3D modelling at a high level has been important in telecommunications for a long time. However, with 5G on its way, it's more line of sight, and understanding the 3D built environment and the types of things that may get in the way of signal is incredibly important to future planning. However, of course, when you start looking at things such as those three major industries without sort of talking about others, and you start thinking about Australia, we have a bit of a challenge. The tiny little dots to the top up here above the lovely big circle is where 90% of the Australian population lives. It's quite a small percentage of the actual area of Australia, and it constitutes around about 44,000 square kilometres versus the 7.6 million square kilometres of essentially rural area across Australia. Further analysis of these little spots gives us a little bit more of an information about the major cities and the percentage they make up. But what's more important is the percentage of total population that's actually made up by a number of the smaller townships across Australia. And as you would know, they're quite a large focus area for government at the moment in particular as to how better utilise our local townships. That means that we've got a lot of area to capture, incredibly large country, You can't do it via too many means other than satellites. We partnered with Digital Globe through this after quite an exhaustive analysis period to get through it all. When we look at something like satellites, there's a few cool facts that most of the Digital Globe satellites travel between 600 and 700 kilometres above Earth, and they travel anywhere between about 25 and 30,000 kilometres an hour. When they're doing that, they're picking up pretty pictures on the ground, but of course, pretty pictures aren't much unless you do something with them. Digital Globe also have a sub-company called TomNod. TomNod is essentially crowdsourcing, but it's used in multiple ways. One of those ways is that you actually use the TomNod crowd to actually produce some of the building outlines. The initial cuts of building outlines each area we go around Australia is essentially done by hand as a training data set. And that training data set basically goes into what I call an electronic brain, but essentially it's a machine learning platform. And this happens on the geospatial big data platform that Digital Globe run, or if you're trying to Google things, just do GBDX. Of course, these things are only capable, and I've got to talk about it a little bit, because of cloud capabilities. To process 50 centimetre pixels across 7.6 million square kilometres of Australia needs a lot of processing power. And luckily, that processing power is available. But what's a little bit more exciting even than those things and getting building outlines and that type of feature extraction is that we're also doing the heights of buildings and trees using satellite-derived digital surface models. And this is basically satellites looking at the Earth at a higher angle so that you can actually get a thing called stereo pairs. And it means that you can actually create a digital surface model and a digital terrain model. When you put all these things together, you end up with buildings. All right. So at this point, before I get too much into this part, does anybody have any questions so far? I take silence as golden, by the way. If you talk to anybody in PSMA, they think that I like to talk. So I like it when I get the spotlight again. Within Geoscape, you have buildings, as well as getting the building outlines in any of the urban areas, so essentially the 44,000 square kilometres where 90% of the population live. In those urban areas, we also do the eave height and the maximum roof height for each of the buildings. The eave height is basically an average around the outside edge of the roof line, so it's essentially where your gutter sits on a conventional house. Of course, it's not a gutter when you get to commercial buildings, but it's basically that leading edge of the building. The maximum roof height is the highest pixel. So when we create the stereo pairs and do the digital surface model, it's basically the very highest 50 centimetre by 50 centimetre square that comes back in the digital surface model. We also pin a number of things to the building. So each building is pinned with address details, cadastral details, as well as localities, mesh blocks, and a range of others. As well as buildings, we capture trees. With the trees, it's a 2-metre raster layer. There are currently geotiffs in the data. That's one of the things that will be talked about by Maria a little bit more tomorrow. But with these 2-metre pixels, wherever it's validated as being trees, we basically put a height to each of those 2-metre pixels. So it doesn't define an exact tree. It basically says that this is what's on the ground and this is how high it is at that point in time. And the rest of what is on the ground is in the surface cover, which again is a 2-metre raster data set, and it categorises things such as water, grass, unspecified veg, trees, built environment, road and path, bare earth. So if we look at a pretty picture, this is an image over Adelaide. When you look at Adelaide, whilst you can look at a satellite image and think that it looks great, What Geoscape does is it actually starts giving you information over the top of this. So it lets you know the buildings with relationships to swimming pools. It gives you an idea of the roof outlines and roof structure, as well as the materials that the roof's made from. We pin the buildings to the planning zone information, which separates it into all of your higher end categories, such as commercial, industrial, residential, mixed use and the like. The 2 metre surface cover covers all urban Australia. Buildings with solar panels are indicated across all of the urban areas as well as the tree heights we spoke of. And one of the most critical things is this pinning to the foundation data. What that does is it means that you don't actually have to look at Geoscape to extract the value out of it. You can actually use it pinning to either statistical boundaries or to LGAs or to suburbs or an individual address level. And you can actually extract information from that rather than having to look at it. So essentially you can dump it out into a whopping great big Excel spreadsheet if you really wanted to. Most of the attribution I've already been through. However, in the product description for Geoscape, there's this lovely table and it goes into a little bit more detail. It tells you a little bit more about the elevations that are provided in there, where they're provided, and things such as the residential indicators and the like as well.
So we'll just pause there for a minute. There's a question around, do we know the tree species? No, we don't.
No, we don't know the tree species. However, because for Geoscape, they're actually using WorldView 3, which is a 16-band satellite to capture all of the urban imagery. It's actually got shortwave infrared bands on it, as well as the near infrared and visible bands. That is making it a lot more likely that species analysis can be done. And I know there's a couple of researchers currently playing with the digital globe data over some of the urban areas to specify vegetation type. I'm looking forward to it coming out. I've told them that I have to be the first one they ring when they get it sorted.
And then a follow-up one on how do you distinguish the building footprints from the roof and eave outlines?
So the roof outline is what we provide as the building outline essentially. Defining that is a bit of magic wizardry that happens with one of Digital Globe's providers. And they essentially use training data to find objects of a like shape, and it analyses it, finds the shape, defines the shape through, and then it also puts a quality match on it. And that quality match is then used as part of the QA process once the buildings are done. And then a certain percentage of all of the buildings are then looked at manually to make sure that they are correct. And if they're not, they're actually manually fixed. That only happens with between 5 and 10% of the buildings, depending on the exact area that it is.
I hope that answered your questions. Okay, we'll keep forging ahead. Great, thank you.
Cool. When I talk about the urban coverage of Geoscape, because PSMA is government owned, even whilst we are commercial, we do have a very strong public good requirement within what PSMA does. And that means that even little country towns such as the one on your screens is actually of importance to PSMA, and we don't believe that they should be forgotten in any of this as we go. So we actually capture these little country towns in exactly the same detail that we do in the middle of Sydney, Melbourne or otherwise. But of course, we don't forget about rural Australia either. So rural Australia, we still do the building outlines. We don't do things such as swimming pools, solar panels or height information. And the surface cover is dropped back to a 30-metre surface cover. But essentially, one of the biggest things is that we drop that height characteristic. We do have an elevation on them, however. We would have thought that there's around about 3.5 million buildings greater than 25 square metres across Australia. One of the more important parts in rural Australia, though, is being able to pin these buildings to addresses. And in rural Australia, in Queensland, it drops down to about 90% of rural buildings have been associated with an address. In South Australia, it was 97.5%. We'll know the full statistics for the rest in June as that one comes out. Where that's really important is things such as service delivery, knowing exactly where you're going to be servicing people. A little bit around coverage, and these maps, depending on what your screen is like, these maps are either come up good or a little bit too washed out, but we can send out some other images. In the map that's currently on your screen, all of the red areas are footprints already captured and released. The orange ones are the planned footprints to be released in June, which are on track at this point. And the blue areas that you can see are the urban areas of interest that are yet to be captured and scheduled into a release. To show those off in a little bit more detail, you've got Western Australia, so all West Australian rural will be in the June release, as will Perth and a number of the other urban areas along the coast around Perth. South Australia's reasonably well covered, but as you can see, there are some blue areas of urban townships yet to be released. In Victoria and New South Wales, all of the rural will be released in June. Sydney was released a month and a half ago, as well as Canberra has been released and a chunk of the South Coast already. In Queensland, there's a few areas that will be released, but we've already released rural Queensland. There are some areas up along the coast for urban that will be released in this release. The rest of Brisbane, all going according to plan, will be released in September. In terms of maintenance for such a product, you can't recapture Geoscape every year. That's taking 18 months to release it the first time. So what we're looking at is replacing large chunks of the highest growth and highest change areas and then sporadic fill around those essentially. And we use our other data sets to know where all of that is and sits. In terms of some of the use cases, and I've spoken about some of the industries previously, but one of the cool ones to go looking at that's currently being released, I don't know why that just went forward, is Geo Vision. Geo Vision is a Pitney Bowes product, and it's a cool way to actually see, if you look at the screen, essentially you can pick anywhere and get a whole heap of associated information where addresses are linked as well as Geoscape linked together, all on a nice little web page, so you can have a play with that.
We might just pause for a minute just to make sure everybody's got their microphones muted so there's not feedback. So if you could just have a glance down and mute your microphone. Thanks very much. Back to you, G.
Cool. Some of the use case scenarios, though, that we're coming across, and we come across more of them almost every day, as well as the standard emergency management. It's a little bit more around some of the pre-planning activities and being able to know what's happening outside of the areas they would normally do high quality data captures for. In terms of city work, it's just an amazing amount happening in Australia at the moment around planning our cities better and planning the country areas around our cities a lot better. Telecommunications, we're in all sorts of modes around telecommunications for 5G and fixed wireless analysis for line of sight, as well as detection of existing black spots with much finer grain data than what's currently used in the industry. And we've got areas such as policy development in government, where you all of a sudden can pin address to an exact location where a service is delivered. And that for entities such as your utility providers, as well as navigation, but also medical service delivery in rural Australia. And that's a really important part as we go forward with Geoscape. We're almost to the end, so then I'll take a breath. However, I suppose to wrap up and summarise what it is that we're doing with Geoscape, is we're focusing on delivering the quality data, building on what we currently know with our products, maintaining it so that you can constantly trust it, but also having it so that that data is constantly there. So as entities can use more and more of this information, they can actually grow at their own pace and innovate as they go. We've got a number of people that are currently using just the 2D building outlines because that's where they're currently up to, but they're looking towards what they can then do for the 3D work as the systems can mature around what they're doing internally. So where to from here? Really, one of the first places to start if you haven't been there is go to the Geoscape website, which is geoscape.com.au. At that website, there's a number of things that you can find from it. One of it, of course, is some of the documentation. Anyone that hasn't seen the data product description and has any bent of being technical in their mind, it's a really good read. It probably is large enough to be bedtime reading. However, if you go through it and pick the key parts out of it, it's very good in terms of the detail that's provided around quality as well as the attribution and all of the data models that sit in there. Many of you on the call have also downloaded the sample data. You can do that off that website. You essentially get sent an email. You can then download the information. In there, you've got a folder, and whilst you've got a QGIS project that makes it really easy to visualise it, in the Geoscape evaluation, you've got different data formats. So you've got file geodatabase and shape files and map info tab files in there. And we've also included some other data that's not in Geoscape, but gives you an idea what it's linked to or what's around it, such as the roads network, addresses, and cadastre. If you open up the QGIS project, you basically see something like this, and then from there you can actually use the buttons down the side to switch layers on and off across it, and you can zoom in and out. QGIS is just an easy tool for people to be able to access. We provide our data through our partner channel. Our partners vary in size and also their capabilities right across Australia. And they specialise in different fields, such as emergency services or telecommunications, or some of them around government policy even. You can find resellers on the psma.com.au website under Get Data, and you can look at it in there from that. And I believe Marty's just put links to all of that in the notes that you should be able to pull up on your screens. In terms of a rollout map, the rollout map is on the geoscape.com.au website. I recommend you to constantly check that out. Changes every time we do a release, and let you know what's coming up the next time. And of course, send us any requests if you've got more questions, or if you would like to know a little bit more about the product, of course.